talk more about lists and lists in particular and classes in general, correct? So last time we saw what is a class. A class is a template for template for an object, and you make instances of that class called objects, correct? So these are correct. Now, so everybody can hear me and see my screen, huh?
Yes, sir.
Okay. So objects are so the class defines the type of the object, and these objects can be stored as values in names, or variables are called names, so they can be stored in names, correct? And we talked about abstract data types in general. We saw stack, and then we started talking about lists, correct? So lists implemented from scratch as abstract data types, correct? And now, so we had, let's call the data type as node. So we have this class node, correct? And in this template, you have to first define how to initialize the node. Not first, but it is a good practice to initialize how to initialize a node. So you say def underscore underscore init underscore underscore. This is an inbuilt, this is a reserved way of specifying the init function. So this is a reserved keyword. This is a keyword, and it is used as constructor for whichever class it is used in, correct? So the first argument is always self, which stands for the object itself. You can refer to the object inside a particular function using self. And then you give, let's say, an init val equal to none. So this is the init val gets a default argument of none. And now what does a node look like? A node looks like, so this is our node. It contains a value. So you say self dot value is equal to init val, correct? And it contains this field, and the second field is next. So it points to another such node. It can be used to point to another such node, correct? So you say self dot next is equal to none, correct? Are you with me? Okay, so you can use it to denote such a list. Next points to another node, and that has a value, and so on. Okay. So now, what are the functions that we want to implement here? So three easy to implement and fundamental functions are methods are insert, delete, and append. Correct? So what does insert do? Insert v, so we would like to say self dot insert v inserts v in the beginning of list. Correct? headed by self, which is pointed to by self. Correct? Delete self dot delete v deletes v from the list pointed by self. Now there is some ambiguity. What if the list contains multiple values which are equal to v? So let's resolve this by saying delete the first occurrence of v from the list pointed by self. Correct? And append v adds a node with value v at the end of the list. So I insert a node with value v in the beginning of the list. This is at the end of the list. Okay. So is the specification clear? Are you there?
Yes, sir.
Okay. Okay. So so last time we saw some versions of append and insert. So we saw a version of append which was recursive. So it is based on so couple of cases. First, okay. So before that, let's define a function called isEmpty. Okay. When is the list empty? When the value contained in it is none. Correct? That is the only case in which it's empty. So, okay. Now let us see how to define append. So how would you define append v? Tell me. So first you check if is empty. If, sorry, I'm making mistakes. So here I have to, of course, give self as an argument. Append self, comma v. And when I call is empty, I have to specify self. If self dot is empty, then what do I do?
We can change the value to v.
We can change the value to v. So self dot value is equal to v. That's the first case. Now, okay. Else if what is the second case? It's not empty, and there is no. So self dot next is equal to none. Then what do we do? Meaning the first case we dealt with was this case was just you have a this is pointing to none and this is pointing to none. The second case we deal with is that this is pointing to some v naught, some value v naught, and this is pointing to none. So this is what is called a singleton, and this is the empty list. Correct? So in the case of singletons, what do we do?
I guess self dot next is, self dot next dot value is equal to v.
But you have to first define self.next. Self.next is none. So if you just say self.next.value, then it will access none.value. Correct? So first you have to create a value. So you say, what happened? Sorry. Where is this one? So you say self.next is equal to, you create a new value. How do you create a new value? Node V. You create a new node and attach it to self.next. Correct? So in this case, you go from here to here. This was V0 and this is V and this is none. This is created by your call node V. Remember, node V calls the init. That sets the init value is this value V that we have provided. So it says the self.value equal to V and self.next equal to none. So it creates this node and we add it to the first list. Correct? Do you agree?
Yes,
And if it's
okay. Sir, I didn't understand the note part.
Huh?
Can you please explain the note part once again?
So you have to create a new node which contains the value V. Remember, what did we say? Self.insert V inserts a node with value V in the beginning of the list. So you are correct. What I was saying was wrong. So what is wrong with it? It would, no, we are doing append. Sorry, we are doing append. Sorry, my mistake. So it's fine. So we are doing append. So the list contains only one entry, a singleton, and you want to append at the end of it. So you create a new node by node V. Node V, when you say node V, it goes to the init for node and calls the init for node, correct? With the init value being set to V, this V, correct? So self.value would be set to V and self.next would be set to none. So this node V returns such an object and you put this pointer to this object. Is it clear? Are you with me?
Yes, sir.
And this was empty list. So we have handled the base cases. So now we have to handle the major part of, do the major part of the work, which is very easy if you think of it recursively. Correct?
Sir?
So you tell me.
No, sorry, what would happen if we didn't put a node? I didn't understand.
Sorry, what would happen?
If we didn't use a node, what would happen?
So if you don't, where would you store the value V? The option would be to say, like somebody suggested, self dot, so I would write it here. 1 second, just give me 1 second. So I will write the wrong code here, which is to say self dot next dot value is equal to V, correct?
Yeah.
Self dot next is not defined, and not defined meaning is none. So when the when Python tries to, when this code is run, this would evaluate to none, and you would try to set the value field of a none object to V, which would raise an exception.
Oh, okay, sir.
Correct? So, so this would be wrong. Therefore, we do this, whatever I have written below it. Correct? This one.
Yeah, yeah. Yeah, sir.
Okay. So these are, we handle the base cases. So now what do we do? Now we have to handle the rest of the thing, correct? So we would say else, this is the last case. And if you do it recursively, you would just say self dot next, sorry. So what would you say? Self dot next is defined here, correct? Remember, else self dot next is defined, because otherwise we would have caught it in the previous case. So self dot next dot append v, correct? So now one question, can you write this? So now I will write two versions of it. So let's write one version. So this part, of course, remains the same. Sorry. The first base case remains the same, but then I say, so I want to do this using exceptions. So how would you do it using exceptions? So I would say else try. Correct? So what would I try? I would try to just do self dot next dot append try v, correct? And if self dot next is not defined, then you would get an exception, and then you would just do self dot next is equal to
node.
Node v. Yeah, correct. So this is another way to write the same piece of code. Arguably, it's slightly simpler. Well, it's not really, but this is another way to write it. But more fundamentally, now this would, so when you execute either piece of code, it would for example, if you execute this append, the base append that we defined, and you have a list of say 1,000 nodes, correct? So append would call self.next.append, and that would call self.next.next.append, meaning whatever was. So it would go through the list, and every call, every element in the list would generate a new call on top of the previous one, correct? So basically you would have, so if you have this list which looks like 0, 1, 2, correct, 3, then the number of calls on top of each other would be as many as the length of the list. Because first you would call with this list, with self being here, and that would call, so it would put this pointer here, in the stack and call the next one, correct? Which would put this pointer here and call the next one and so on. So your call stack would build up, correct? You see my point? What is the height of the call stack? It would become equal to the length of the list, which might be very expensive, which will consume a lot of resources and is very, it uses a lot of space and it also uses a lot of overhead. It has a lot of time overhead associated with it, correct? Because procedure calls are usually expensive, correct? So how would you try to cut down on the running time? Tell me. So you would try to do it iteratively. Basically, you want to go over the list, and when you reach the end of the list, you want to append the thing there, correct? So you would define, you can define a procedure called def append iter self comma v. And what does it do? So the first case remains the same. If self dot is empty, self dot value is equal to v, correct?
The node v
is equal to v.
okay.
You are storing the value, correct? Just the value in this. If it's empty, then you put the self dot value equal to v. In value, you don't store nodes. You store node in the next pointer, correct? The next pointer points to a node. Are you with me?
Yes.
Okay. So otherwise, what would you say? While okay, you take a pos is equal to self. So this is your list. 0, 1, 2, and suppose this is none. So you do pos equal to self. Now self was pointing to this. Now pos also points to this. Now you want to go move pos to the end of the list, correct? So when do you know you are? So you will say while pos dot next is not equal to none, correct? And what would you do? Pos equal to pos dot next, correct? So first it's pointing here, and irrespective, so you would move pos to else, it's not done. Here you stop, correct? Do you agree?
Sir?
And,
No, okay, so what are we doing in this code, like this program? I didn't understand. And
So in this piece of code, we are not using recursion. We are using iteration. We are writing a while loop, and we are still appending. We still want to append the end of the list. Then we complete the code. Correct. So you are iteratively going over the list, one node at a time, till you reach the end of the list, and at that point you just attach v, correct? And this is the only exception, which is if the list is empty. That's a special case because the node is there but it doesn't contain a value. Then you put self dot value equal to v, else you just iterate over the list and attach the value at the end of the list. Do you see my point?
Yes, sir. Yeah.
Sir, it's just V, right?
Huh?
Is it just V or
pos.next equal to, sorry, I was wrong. So so I was wrong. It will be pos.next equal to node v. So you have reached this point. This of course has a value. If you put it equal to v, then that will be wrong. If you put it node v, that will be doubly wrong. So here pos. We know that from the previous two lines, we know that pos.next is none. We replace this by v. Correct? So we remove this, put this pointer to this one, and this is pointed to none. Correct? Sorry. So now do you agree it's correct? Do you agree?
yes, sir.
Okay. So this is append iter. Now the next thing we will do is def insert, which we saw last time also, and I will not go into too many details there. But I would like to remind you that the way we did it was to replumb, so do rewiring, correct? And what was the rewiring thing? Why was the rewiring thing required? Because you have this list 0, 1, and so on, and you want to attach v here. So self pointed here, you wanted to attach v before 0, right? In the beginning of the list. But you cannot change the value of self outside. What self points to outside will not change. Outside the function call, correct? So what was how did we do it? We spliced in, so we removed this pointer, spliced in the new value here, and then took this value, put it here, and put v here. Correct?
Yes, sir.
Do you see my point? Yeah. So should I write code for this, or is it clear? Anybody wants me to write code for this, or is it clear? Does anybody want me to write code for it? If not, then I'll assume that you will look at the last lecture and we did. Oh, let me write it. Why should I not write it? No good reason. So again, if the special case is if self dot is empty, then what do we do? Self dot value is equal to v. Correct? Now you want to splice in this thing. So so there is one more case, which is else if self dot next is equal to okay, that's also not a special case. Okay, fine. So else, what do we do? So let's finish this part here and write the code after this. So you would take self dot next this pointer and save it somewhere. Correct? So is equal to so you would save it in a temp. You would save it in temporary this thing, correct? Now you create this this object with the value, which is the value of the first one, correct? So you'd say self, sorry, what am I saying?
So like
Tell me.
self dot next equal to node of the node of self dot val.
Self dot val, good.
Self dot next equal to
Yeah. Okay, good. So self dot next is equal to self dot next is equal to 10. So the first thing was, so there are 3 steps, 1, 2, and 3. The first step is which one? Temp dot creating this. No. First step is saving this pointer. So saving this pointer in temp. Then you do self.next is equal to node of self.value. So you create this object. This is 2. And then self.next is equal to 10. So you are putting this pointer. Correct? And now you know this thing. So now you have to replace the value of self.value. So you have to say self.value is equal to v. Correct? So this is number 4. This is 4. Correct? Are you with me?
Yes.
Okay. That said, let us move on to delete. And so how would you define delete? What does delete do and how would you define it? So this deletes the first occurrence of v in first occurrence of v, correct? In the list headed by self, list pointed to by self, correct? So how would you do it? So firstly, so there are many cases. Let's note down the cases first. So the first case is, case 1 is you have a empty list. The second case is you have a singleton. 2A is you have a singleton with value v. 2B is singleton not value v, correct? And the third case is that you have a longer list, long list, meaning more than one length, and which might or might not contain v, correct? So the first, this case 1, 2A and 2B are easy to handle. So how do we handle it? But in the long list case, notice there is a problem. So let me do the naive construction. So and that doesn't work, correct? So the buggy thing, how do you write it? Let's first write the basic this thing. If self dot value, if self dot is empty, then what do we do?
Return.
Then you don't have to do anything, just return, correct? Now, if so it's not empty, that means that it is. So now we check if it's a singleton. If self dot next equal to none, correct? So we are in case 2. we are singleton. This is case number 2. And now, if self value is equal to V, then what do? It's a singleton containing the value V, so we erase that. So we just do self dot value is equal to none, because you have to create an empty list, correct? Which must have this thing. And if it's not, if the value is not V, then again we don't have to do anything, correct? Do you agree? Correct?
Yes.
So now you would think that the simplest way to proceed is via induction, via recursion, and you would do something like self dot next dot delete V. Correct? Sorry, where have I put this? Correct? Now tell me, why does this not work? Or what problems will arise if I do this?
There will be a none in between.
There will be a none left in
between.
between. Yes. Why is that? Because you will have something like, suppose you are doing delete. So suppose you have a list which looks like 0, 1, and 2. And suppose you want to delete 1. Correct? Suppose you want to say delete 1. Correct? So you would check whether self is empty. No. So you would go to self.next equal to none. That's not true. So you would delete this one. You would reach delete of with this mode. And now you would check if self is empty. No. If self is next is none. No. Then you would so firstly you would just bypass this. So this one is very buggy. Correct?
So could you repeat the buggy way? I didn't understand.
So the buggy part is this is so you would I wrote a very bad piece of code. What is the thing that you want to delete 1, correct?
Yeah.
If you delete 1, you will reach this node after the first call from here. So you would call delete with self being this, you would call delete, correct? You would then go through the code. You would not find any case that satisfies it. You would reach the last line and you would call delete with this, delete 1, delete with this pointer, self being this, correct? And now no case will match again. So you march forward, leaving 1 behind. So how do I fix this?
So I don't understand. Why would it leave 1 and go?
So where are we checking? It would check if self.next equal to none. Is self.next none? No. So it would say self.next.delete. It does not check for V. So the one mistake that I'm making is that I should interchange these 2 lines. Correct? But now, now what will happen? So this is still buggy because you would, okay, self dot none is none. So self dot none is not none. So you would just not change the value of this. So it is still wrong. So what would you do? You would in the simplest case, you would remove this and just say this thing, self dot value equal to none. Correct? This is what you want to do. Correct?
Okay, yes, sir.
Now it is still buggy. Why? Because suppose you wanted to remove 2. Instead of 1, you were calling delete 2. What would happen? Or even with 1, what would happen? You would set this to none, correct? Even with 1, delete 1, you would set this to none, and then you would be left in an inconsistent state, correct? So you don't want to set the value to be none. What do you want to do? You want to splice out this element and put this here, correct? Do you agree with me?
Yes, sir.
But do we have at this point this pointer which we want to set to here? That is the previous elements next. Do you see my point?
Yes, sir.
So we have no way to access it. So we are stuck. So now what is the way to go around it?
So we have to carry it.
You can either carry that previous pointer or you can look one step ahead. So let me try again. This is wrong. So let's say def delete self comma v. So if self if self dot is empty, then what do we do? Then of course we return. Now we know it's not empty. If self dot value is equal to v, correct? Then we have to delete it. So how do we delete it? We want to splice out this thing, correct? So suppose this is at the beginning of the list, correct? Self dot value equal to v. Now we check if self dot next. No, sorry. So then we just do. Let me write the code and then I will explain. 1 second. So I will say self dot next self dot value equal to empty. Is none. Else I will and I will return. This will only happen at the beginning of the list, correct? Now I'll check also if self dot next, if self dot next equal to none, then sorry. So, okay, 1 second. So, sorry. If self dot next equal to none, then I don't is not equal to none, then I proceed further. And here I check if self dot next, sorry, next dot value is equal to V. So now I'm checking one step ahead, correct? And if self dot next dot value is V, then what do? Then I splice out that thing. So I say self dot next is equal to self dot next dot next. Okay? I have spliced out this item, correct? And
So could you explain how that worked? How you spliced out the...
so I'm saying, so let's no, I still have to write out one more this thing, which is just give me 1 second. Self dot next dot delete V. So now how did I splice out? So let me take the same example again. You have 0, you have 1, and you have 2, correct? And suppose you want to call delete, so self points here, delete self dot delete 1, correct? So this is 1, correct? So you would check, is self empty? No. Is self dot value is equal to V? No. So you continue further. If self dot next is not equal to none, so now you are in this case. Now you're seeing one step ahead. If self dot next dot value equal to V, self dot next dot value is indeed V, then you do self dot next. Self is, remember, still this. You do self dot next is equal to self dot next dot next. This. So you remove this and you put this pointer. Correct?
Yes, I get it. I understand.
And so self dot next, and you return. Correct? Rather, you should you also return in the else case. So let's put it 1 second. Let's write return here. Correct? So whether or not the no, 1 second. No, sorry. My mistake. So what should I do? I should write if self dot next dot value is V, then self is equal to self dot next and return. Correct? And if the value is not V, then I have to delete this in the next. Correct? So I should move this here. Correct? And if so, do you see my point? And if the
So
self.next, tell me.
Sir, will this delete all V's?
No, this will delete the first V. Deletes the first occurrence of V.
Sir,
Hmm.
in the second if block, I think we might need to also add the condition that, so because here if V is the first element of a longer list, it will still change it to none and return. So
Yes. So if V is the only element in the list, it would change it to none.
no, sir, I think it will still change it to none if it's the first element in a longer list. Because this will be the.
That's a good point. That's a good point. So, so how should we reorder this thing? We should say the simplest way is not the cleanest way, is to say if cell.value is equal to V,
We just have to put an else right before that last statement.
no. You have to say self.value is V and self.next equal to none. If the value is V and it is a singleton. So at this point, I'm saying it is a singleton V. And if it is a non-singleton V, I don't have to do anything. So, so you're correct. Then I should either put, yeah, so then I should put a else here. Because if the value is V and self.next is none, that means we are in a singleton V and we return, correct? If the value is, so if the value is not V, then we would go, then we don't have to do anything. And it's still a singleton, then we don't have to do anything. So that, so how do I convince you that this piece of code is correct? Well, so firstly, do you see that it intuitively feel that it is correct?
Sir, now it feels like it just misses if, like it completely misses the first element if it is like V. Because
No,
it will.
No. If cell.v equal to V and cell.next equal to none, then you would enter this. If cell.v equal to V and it's not none, then it would enter this case. Oh, that is also true. Sorry. Sorry, that's a good point. Sorry. So let's put this inside and if inside an else inside this. So okay. So no, first let us decide whether it's a singleton or not. That is the best way to do it. Correct? So let's say this and sorry. If cell.next equal to none, then so this means it's a singleton. It's a singleton. If cell.value is V, then cell.value equal to none and return. This is still buggy, isn't it?
Sir, like I think that the first code that you wrote was correct. Just you have to write an else before the last statement. Like the last if block, after the return, you should write that. I think that.
No, one second. This piece of code, is it correct or not? Would it, so tell me.
But I think it still misses a
The
weaving
last-
at the beginning.
At the beginning. If self dot next equal to none, if it is a singleton, then it doesn't, correct?
Yes, sir. If it's a singleton, it will catch it. But
If it's not a singleton, then it would go to else.
Sir, instead
Oh.
of this, we could do that.
Yeah, it still misses the first V. And so 1 second. So if self dot value is equal to V, then I mean, the obvious way is to list all possibilities and do it, correct? Now we want to, at the same time, want a clean code. That's why it's getting this thing. So let's list all the cases.
Excuse me, sir.
We started. Tell me.
Sir, could we write this if self dot value is equal to V, self is equal to self dot next?
Self dot value equal to V, self equal to self dot. Yeah, you are writing an iterative procedure. That you can do. Right now, I'm talking about recursive, where you're calling delete recursively. Correct?
Yes, sir.
Do you agree? Correct? So, 1 second. So, let's. So, if it's a singleton, if it's not a singleton, we have to handle that case. Correct? So, self dot next is not equal to none. Okay. And this can only occur in the first place, correct? So that was the mistake we were making. So the splicing out is not correct. We should I mean, we cannot change. So this is like replumbing again. We have to do replumbing. So if you want to delete 0, what will you do? Suppose this is your list. You want to delete 0. That is the case we are getting stuck in, correct? So you cannot move self here because you cannot change the value of self outside this thing. On the other hand, you could copy this thing here and splice this out, correct? So where should I write this code? I should write this code where self.next is not equal to none, correct? In this part of the code. So how do I write it? If self.value equal to V, then what do? This can only occur in the first place. When V is the first element, correct? Then what do? Self.next, so self.value is equal to self.next.value and self.next is equal to self.next.next. So you splice out the first element by using replumbing, correct? And this I will change to else if just to be sure.
In place of those two lines, like Swaminathan said, could we do self is equal to self.next?
self equal to self dot next. So let me write that. That is an iterative piece of code. Na?
So, but is it different from saying self dot value is self dot next dot value and self dot next is self dot next dot next?
No, you want to do it recursively. You want to do it many times. The self is. So what are you saying? Tell me again.
So what I mean is, instead of the two lines self dot value and self dot next, we're assigning those there. Instead of
Yes.
that, like Swaminathan said, could we do self equal to self dot next, just to make those two lines into one?
No, that will not work. Why will that not work? If you
So
do
is it because
self is equal to, because if you do self equal to self dot next, then the value that is pointing to this will not change inside this thing.
Right.
It would continue to point to this, correct? I thought what he meant was that you do it iteratively. So let's write the iterative version. But before that, let's convince ourselves that this version is correct.
So could you repeat the last point? You said something wouldn't work when Gautam.
So the suggestion was that if self dot value equal to v, we replace these lines by self equal to self dot next. Correct? Meaning you want to skip this from here, start the list from here. Correct? Because we want to delete the 0th element. Correct? The value which is in the first element. Correct? But that is not possible without replumbing. You cannot change the value of self. So when you call this, like you will call something like node v and sorry, what am I doing? So n is equal to node 0, n dot insert or append. Let's append 1, n dot append 2, and then we say n dot delete 0. Correct? So n points at this list which consists of 0, 1, and 2. Correct? And what the suggestion was, self points to this inside this delete call. Inside this delete call, self points to this. Now you change the value of self to this, but n still points to the same list outside.
Oh yeah.
Correct? So even if you change the value of self, it will not reflect in the external variable. It would continue to point to the same thing and nothing would happen. Correct? Even if you remove this, then you would lose the list totally. Correct?
Okay, sir. Yeah.
So instead, we have to do some replumbing here. A slightly neater but much more inefficient way is to continue to do this at every step. Correct? So a neater but much more inefficient, meaning it would go over the rest of the list also, would be to even after finding v, would be to do what? If self dot value equal to v, then do this. So meaning I mean, suppose you wanted to delete all elements from v, then how would you rewrite this? All occurrences of v.
So you don't return?
Huh?
In the last statement, we should remove the return.
This one. This one?
Yeah.
If we remove it, but then we don't even need this clause. This entire thing would go.
So I think we don't need it even if we are just checking for first way.
No. Sorry. Ignore what I said. So currently deleting the first version, does this work? I've not thought about the other this thing. So does this work? There you would have to shift many things maybe, but yeah. So tell me, questions, comments?
So I think we don't need that last else if even if we're looking only for first visa, because I guess what we are doing is checking. Oh no.
No, we need it.
No, we need it. Yeah, sorry.
We need it because only this occurs in the first place only. Sorry. This part will occur only once at most.
Yes, sir. Yeah.
Thereafter, you know that self.next.value is what you're looking at, and then you are splicing up actually. Correct?
Yes, sir. Yeah, got it, sir.
Okay. So now how would you do a iterative version of this? In an iterative version, you would maintain a pointer and successively point it to all the elements in the list. And when you find V, then you just play. So basically, instead of this self.next.delete V, you would put this inside the tight loop. Correct? So only the base cases you would put outside the loop, which occur only once. So namely this case and this case, meaning from here to here. Correct? These occur only once, and the rest you would put inside a loop, and meaning this one. This case you would put inside a loop, and when you find it, you splice it out and return. Correct? So I will let you write the iterative version, but if you have questions, ask me. So here, one thing which I would like to point out is when I spliced out here, or when I spliced out a part, one node in the list from here, correct? So I removed this pointer and put it instead here, correct? In this case, what happens to this pointer, to this object? Is left hanging, correct? It has no incoming, it has no incoming pointers. It is a hanging object. It points to something. Yes, it points to this, correct? But it has no incoming pointers. So it is a piece of memory that cannot be accessed from anywhere. It's not, its value is not stored in any variable. Correct? Do you agree?
Yes.
So it is cleaned up by the language, by the interpreter. Correct? Periodically, there is so-called garbage cleaning, which remains everything, all those pieces of memory which are inaccessible from the rest of the program. Correct? In C or C++, you have to do this explicitly. Explicitly or implicitly, you have to do it. In C, you have to do it explicitly. You have to clean up everything. In C++, you have to write whatever it's called, destructor to implicitly clean up when you abandon an object, so to say. Otherwise, it will stay in memory and cause a memory leak. Meaning, part of the memory will not be usable by the rest of the program. But in Python, it keeps track of which portions of the memory are not reachable from anywhere else, from the variables in the program, and it cleans them up periodically. Just frees up the memory periodically. This is called garbage cleaning. Correct? Do you understand the idea? Correct? Are you with me?
So what do you mean by unreachable portions?
Unreachable portions like this thing which was 1, when I called delete 1, correct? The only thing that was pointing to this was this pointer, correct? Was the pointer from 0 to 1. Now I've shifted it from 0 to 2. So there is no incoming pointer to 1, assuming that other variables do not contain a pointer to 1, correct?
Yeah.
So it is a hanging piece of memory which is not reachable from anywhere in the code.
Oh, okay.
Hereafter in the code, you cannot access it. Correct? And
So
the
this is
compiler maintains all the incoming pointers of into a memory location. And when this count becomes 0, that memory is just garbage, and you can clean it up.
Yeah, okay, sir.
Correct? But this has a flip side to it, garbage collection, sorry, which is that you do it periodically only, correct? Because you don't know when such things would be created. And when you are doing garbage collection, then that devotes part of the processing to garbage collection, correct? So your actual program might slow up. Do you see my point? You can do this garbage collection at any point of time after some memory location has become garbage, but doing so will expend some of the processor resources, and that might slow up the rest of the program. So if you have a lot of garbage in your program, it might become slow periodically. Correct? So that is a disadvantage that is not there in C. On the one hand, this garbage would stay in memory, but there is no slow up associated with it. If you have a large memory, there is no problem. Correct? You see the flip side of garbage collection?
Yes.
Okay. So that's all for today. If you have more questions, ask me. Otherwise, we meet on Tuesday.
So why do we need to clean up the garbage? Can't we just leave it as it is?
If we leave it as it is, then if you're not careful, then the memory will pile up. This garbage will pile up, and if memory is an important resource, then you would be left without memory soon if you don't garbage collect. Correct? Or you don't explicitly destroy the garbage.
But can't the compiler just override those memory locations when it needs more memory?
Not the compiler, the interpreter.
Yeah, I mean that.
So it's not at compile time. There is no compile time here. At the interpreting time, at the run time, it does that, but that expends resources. You'll have to find the parts of memory which are unreachable and then clean them up. Correct?
That is only technically the garbage collection thing, right? Like, I mean, that is also requires that space of requires that much resource to find those garbage places. And
meaning you have to maintain a list, some data structure in which all the pointers are stored. You have to identify which ones have 0 in degree, those memory locations, and then you have to remove them from the rest of the thing, and you have to compactify the space and things like that. Correct? So that requires computational resources.
so which is faster in general, like garbage collection or that type of thing that we will?
Garbage collection is better for space.
Yeah, like in the sense of even time complexity,
In
which
time
will be
complexity,
faster.
C is much better. The without garbage collection is much better.
No, we restrict the space, and after the memory runs out, we find those garbage areas and then override those memory. That would be faster, or what Python does for garbage collection is faster.
No, when the memory runs out, then your program crashes essentially.
No, you were telling if we somehow like we override those memories which aren't in use, like unreachable memories or stuff.
Yes.
Will that be faster, or garbage collection in itself is faster?
No, overwriting that memory is what is garbage collection.
Okay, please.
Garbage collection consists of overwriting the memory, reclaiming the garbage memory into the so that it can be reused. Correct? That is what is garbage collection. In C, it is not there, but on the other hand, if you write your program well, you at every step you remove anything that you are not using. Correct? Then that is time efficient wise, it's very time efficient, but then you have to be careful about this. Correct? So you have to guard against leaving large chunks of memory. Leaks are quite often there in C programs. So is it clear? The basic idea, is it clear?
Yes. Also, another question, like in append try, we use the error handlers to actually do some sort of like conditional statement. So does that affects the speed of the program? Error handlers take much more time. Is that so? Like error handlers takes more time than usual.
So that's a good question. That's a very good question. I'm not sure exactly of the answer. I would think it is an expensive process. But at the same time, I have no empirical data to support my claim. And it's certainly more elegant or more, but yeah, I would guess if you have multiple exceptions and so on, you are doing this on the basis of various exceptions raised and so on, it will be inefficient. So Python is not a very efficient language, but it's a very elegant language.
Oh, okay.
Okay.
Sir, in the program for deleting the elements, so if we remove the last return that will it delete all the V's?
If we remove the last return, it will go to the next one and delete it. Yes.
So all the V's will be deleted. So
let me see. Cell.next.delete V. But there might be a problem if self.next were suppose this were none to begin with. Correct? Then this would bomb.
Okay.
So you would have to cover one more case where this next element is, so you would have to write if self.next is not none, then self.next.delete. Correct?
Okay.
Okay, more questions? Okay. So thanks. I mean, meet next Thursday. Okay. Next Tuesday. Thanks. Bye.
Thank you.
Something mentioned about running times and better running times attracting better credit. Just wanted to ask, like,
So,
if you could say a little more about that.
So in general, that is true. In the first assignment, you don't have to pay too much as there's not too much emphasis to be paid on running times.
Okay, sir. Okay.
But I mean, if you do binary search, in the binary search question, you of course have otherwise. So in the binary search question, you have to do it in more efficiently than just brute force search.
Okay. So as long as I've not done anything very time consuming, I should be fine.
Yes. But in the
Okay.
binary search question,
Right.
just as a hint, it takes login time to do binary
Right.
search. While if you do a linear search, it will be too expensive. Correct?
Right. Got it, sir. So yeah. So if the question in specific is looking for something, then I will need to have done that. If
Yes.
not, it should
Yeah.
be
But
fine.
in later assignments, time will be crucial. But I am not yet.
Newton's polynomial method. What would be that take? Like, what's the time complexity? What would be the runtime for that?
So for polynomials, that's a good question. Newton iteration takes. It is. Newton iteration is Newton iteration would be more efficient than binary search by an exponential factor. Binary search is say log n, that will be log log.
Okay. Okay. It converges quadratically faster or something like that.
Quadratically means, what does that mean?
Yeah,
quadratically means that this is linear convergence, correct? It's proportional to the number of bits.
Yes.
There it's logarithmically in the this thing.
Okay, I see.
So let's not get too much into this, but Newton-Raphson is much more efficient than binary search in general.
Okay.
But it might be space intensive, more space intensive. You would have to deal with larger numbers. Correct? Okay. Thanks.
Thank you, sir.
Thank you. Bye.